Microsoft, and a content creator in YouTube who had more than 100,000 subscribers, 100,000 views. He had mentored students in Google Coding 2019 for the TensorFlow organization, and have judged multiple hackathons across engineering colleges in India. So shall we welcome Mr. Vijay?
Hi everyone. First of all, thank you for taking out time and attending the session. I hope I'm clearly audible to everyone. Okay, great. Thanks for the wonderful introduction, Yuan. So yeah, as you mentioned, I work for Microsoft. I specifically work in the Office Android platform team where we build the Word, Excel, PowerPoint applications. And I am also a content creator, more towards the technical content I create on YouTube, and I create content over LinkedIn as well. Today, I'll be sharing my experience. So I have worked with a startup as well, which is a Munich-based startup called Stack Guardian. It is an IAC-based platform, which means infrastructure as code platform, where we automated the deployment of infrastructure over different cloud platforms. And the whole platform was built with Django. Django is a macro framework built with Python. And so we did all the researches, and along the way, we found out, we accumulated a lot of information. We made a lot of mistakes. We did a lot of experiments, and on the way, we figured out what actually works well with Django, and how someone can write microservices, which is very buzz these days in Django framework. So I'll be talking about that only today. So these are topics in the store for all of you. We'll be walking through monolith first of all, and how to move away from monoliths. Then we'll be talking about microservices, why and what are those. Then we'll be specifically talking about Django microservices, how to actually build Django microservices, and then the actual crunch of this particular session, which is the mistakes to avoid while building Django microservices, and then a fun trivia by the end of the session. Moving ahead. So you might have seen this image. There are monoliths appearing in Utah, in US, and there are so many other places. But we'll be talking about the monolith architecture. So what does that mean? So a lot of people have this misconception that monoliths are just huge systems, and everything is combined into one single machine, and the clients are directly interacting with a single machine. And for microservices are tiny systems or machines, and clients send requests to each of those machines, which is a misconception actually. Monoliths we can also scale out monoliths. They can be horizontally scaled out. It's not like there is only one machine when it comes to monoliths. It's just we can replicate it out, and we can horizontally scale it. So if I go through the general since each and every part of a monolith touches each other, if there is a change, and the changes are interdependent, so deployments gets very difficult because since changes are interdependent, there needs to be a proper cycle of deployment. Because changes are interdependent, one change cannot go before the other. Then there will be conflicts, and then the system may crash in future. Deployments are very, very complicated. Any small change require monitoring as well, and monitoring as well as all the teams need to be coordinating with each other in order to make the deployment successful. Then comes testing. Now, as I mentioned, all the components in a monolith touches each other or tightly coupled. There needs to be proper testing required. The test cases need to be, so writing test cases becomes more complex because you need to take care about each and every bit, either dependent, tightly coupled, or loosely coupled. You need to take care of each of the element of that monolith. So that's why the testing becomes very difficult. Now comes the single point of failure. Now what does that mean? So as I mentioned, although we can scale out horizontally a monolith, you can create replicas of it, but you can increase the number of servers in order to increase the compute. But even if there is a bug in any of the servers, since the servers are identical, the computation is identical, even if there is a problem in one of the server, it will lead to a crash of the whole system. And that's why we have a single point of failure in monoliths, and this is one of the major disadvantages with monolith. And then comes the adaptability, which means that since the complete system or the complete application, with time it gets too large and complex, with the upcoming technologies, it's very difficult to move to new technology because every now and then we get to know about different frameworks, different libraries, and in order to ramp up or align with the new technology, if the system is too large, the costing to move from the previous technology to the new technology gets very difficult, and that's why this is one of the major disadvantages with the monolith architecture. Okay. In case, if anyone has any questions in between, please either raise your hand or we can take all the questions by the end of the session. Now, there are a lot of big companies who have actually ditched monolith architecture. And if I name a few, they are Amazon. So if you go to Amazon today, their payment system is a completely different microservice. Their profile is completely different microservice. And their product listing page, each and every bit is a different microservice. Netflix have their payment system, have their streaming system. They both are they are loosely coupled and different services running on different servers. Uber is one of the examples, and eBay is also one of the examples. But what are microservices, and why we actually moving towards microservices? That's the main question. So if I talk about, with a general example, when users or, for example, mobile phones interact with different services in order to get responses as per their requirement. For example, if I'm a user, I'm going to Amazon and I'm looking to my profile, I just need the profile service, a response from the profile service. I don't care about the payment service at this time. And this is where this is what actually the microservice architecture, where different services are loosely coupled and you actually get the responses based on your requirement. So if I talk about, okay, yeah, that's actually, for example, one is the auth service can be one microservice. The payment system can be one microservice. And this is how the microservice architecture is defined. So it's a approach to build components which are loosely coupled, and each of the components are has specific goals with respect to the business, and they are not directly dependent. They are not tightly dependent on each other. Yeah, so that is the general introduction of microservices. But why we actually need microservices? Now, if a platform or a particular a system has separated out the responsibility, they are not directly dependent, and they can work independently and deploy on the go whenever they are ready. Okay. Then improved fault isolation. What does that mean? Now, when it comes to monolith, you don't know. For example, if a system crashes, you generally don't know which actually is the culprit or what is actually consuming the lot of compute. For example, if your system is suddenly started consuming a lot of load, or suddenly started consuming a lot of compute, now it's very difficult in monolith to identify who is the culprit. But in microservices, since there is a separation of resources, there is a separation of services, it's very easy to identify which particular service is actually causing the issue. And that's why companies are moving towards, and these advantages are very convincing, and that's why companies are actually moving towards the microservices architecture. I'll wait for. Okay. But everything has its own challenges. It's not like that microservices is kind of perfect. Nothing is perfect. Perfection is a myth, actually. So even microservices has its own challenges. For example, if a company, so initially designing a monolith is very easy and convincing for any particular platform, and every other company should move to a microservices, not because they want to scale out, but they should uh, they should start thinking about moving to a microservice architecture when their teams actually scale out. When when your team started to grow, your members want to work on uh, different products and want to have ownership of those products. Then only you should consider. Then only a company or a small team should consider moving to the microservice architecture, because designing a microservice architecture is very difficult, because it requires, you know, you need to define the boundaries of separation. Which particular service needs to be decoupled? What should be the you need to define the areas of responsibilities. For example, there is one of the very bad practices being followed while defining microservices is, if a service is only interacting with another service, then you should actually not decouple them, but consider it as a single service, because if service 1 is only interacting with service 2, you should never divide those services into two different microservices, but combine them into a single service, because S1 is only interacting with S2, and since there is a single dependency, one should never, it actually increases the cost, and it's not going to help anyways. So this is one of the major mistakes or major bad practices that companies generally do while moving towards microservices. Okay, yeah, that's done. Inter-service communication. Now, so every particular service needs to get or receive data from other services. In monoliths, what we have is everything is in a single scope, so we just do a function call, and that's how we get the responses out of them, and that's very quick. But when it comes to microservices, we need to do a network call, or maybe a gRPC call, which means a Google remote procedure call. And this requires network bandwidth and requires a lot more time than a function call. And that's where, these are some of the challenges with microservices. Now, in a microservice, each and every microservice should have its own dedicated database. Because if we have a single database, that will cause a lot of conflicts, because each microservice has its own schema, and it will create a lot of load on the single database. Hence, it is one of the good practices to have a dedicated database for each and every microservice, and this leads to a lot of costing as well, because the more the microservices we'll have, the more the databases we'll have, the more computation we'll require, and then the more costing we'll have to incur. Okay, moving on to the next part, which is Django microservices. Now, this is the thing that we actually experimented a lot while working at Stack Guardian, which I already told about, is a IAC platform built completely in Django. We initially started with the monolith architecture. We built everything inside of one single application, and then we divided into different components. One of our components was the marketplace, the other was the authentication service, and then the orchestration service, so on and so forth. So how we actually made that move? So initially, we started with 4 members in the team, and each of the person is actually working on the whole application. It's not like that. We had different roles. Each one of the member know the whole system or the whole code base. But as we evolved and the code base evolved, we added a lot of enhancements. Our team started to scale up, and that's where we decided we should go for the microservice architecture. And that will help us to give ownership to each and every individual in our team. Okay. Yep. The second is define boundaries for each service. Now, when you have a monolith architecture, it's, as I already mentioned, it's very difficult to decouple those services, and that's the most critical part and the most interesting as well. You need to define the boundaries and where to actually define those boundaries. The boundaries needs to be defined where the services are very loosely coupled. I mean, the dependencies are minimum, and so that they can be decoupled, and whenever there's an issue in one service, it should not affect the complete system. Separating resources, that is, adding a dedicated database to each and every service, so that giving a dedicated resource, a dedicated compute server to each and every service, in order to, for example, if a particular service require a lot of, so the thing with microservices is, for example, if a particular service needs to scale out, you can scale that particular service instead of scaling each and every microservice that you have. And that's allow us to separate resources. For example, if auth service require maybe 2 databases or maybe 3 servers, so based on the requirements, we can separate out the resources. Then inter-process communication, as I've already mentioned. So there are multiple ways to communicate between 2 services. One is the HTTP call, and the other is the gRPC call. But what we figured out is instead of gRPC call, we use HTTP calls, which is more of a convention used in the microservice architecture, and we used it for our use case as well. So this is actually the small, the thing that we do at StackGuardian, where we take the inputs from our customers in the form of minimal documentation, minimum YAML files, and then we use that particular configuration to deploy their infrastructure over different cloud platforms. Now comes what mistakes one needs to avoid if they are working with Django and they are thinking to move towards the microservice architecture. Apps and the unfaithful migration. So what happens is, so before going to the major mistakes, one small point while regarding creating apps in Django. So what happens is Django tracks model migrations separately for each and every app. And for example, if someone has foreign key linking across different applications, Django migration system will try to create dependency graphs. And sometimes, and creating those dependency graphs has a lot, it's not perfect every time, and it has errors in it. And that, unfortunately, this calculation isn't perfect, and this leads to a lot of errors while doing the migrations. And it gets, it will affect a lot when there are a lot of, the number of apps are more. So in order, with respect to the apps, if your particular team is, if you don't want to get confused with apps, you should stick with one single application. If you still want to move to multiple applications, so there are 2 reasons why you want to move to multiple application system. Either you want to scale your particular project to a microservice architecture in future, and that's where you need to consider one thing. Either in the initial front only, you should define the responsibilities explicitly, so that it will help you in future whenever you want to move to multiple application system in Django. Squash migrations. Now, what does that mean? So with each and every deployment, Django creates a different migration files. And while deploying the migration the migration, whatever files are created for migrations, each and every file is ran again in the same order. And if you have multiple databases, it will do it for each and every database. Now, here comes the problem where, for example, oh, 1 second. Yep. So as the system evolves, it accumulates more and more migrations, and they will take a longer and longer time to run. For example, if you have multiple applications, multiple databases, it will run through all the migrations. It will run through all the migrations, and that will require a lot of time for each and every deployment. With the interest of time, I'll try to finish it quickly. So as I mentioned, yeah, it will require a lot of, the deployment cycle will take a lot of time. If we have multiple databases, and if we'll do, so migration is required with each and every deployment, and if we'll have a lot of migrations, then the deployment cycle will take a lot of time. So what we did there was, so there are two ways in order to avoid this mistake, avoid this deployment delay. One is either to manually clean all the migrations and then do the migration thing again, or use a built-in feature of Django for squashing. So this practice will help you to actually reduce the deployment time if you have a lot of migrations. Less bulky signals. So signal is one of the amazing features that Django provide, where you can control, you can do a few things based on whatever has happened, based on the pre or the post signals. So for example, if model A is being created, you want to do something with model B. Or for example, if an object is created, you want to do some logic at the back end. So the problem with one good practice that we figured out was, it's very difficult to, or I would say impossible to pass arguments in signals. And second thing is, one should never write a lot of business logic in signals. Because in case if anything fails, it will make things more complex, and the system is prone to problems. Okay, then comes the ORM thing. Okay, so for example, if your system has multiple calls to create and delete objects across the board, you need to, and so there is no clean way to create and delete objects in Django when it comes to a lot of, so in a huge system, generally people create and delete objects at a lot of places in the code base. And there is no clean way in Django to create or delete objects through a single entry point. So it's generally advised to create a wrapper over the ORM that Django provides, which means object relational mapping. So what happens is, when you create a wrapper over it, you'll have a single entry point for all the CRUD operations, and that's where, if anything, you can add changes before and after the database events, whatever logic you want to do before the database events at a single place. So it will actually help the engineers to make the deployment convenient and very efficient. Okay. In conclusion, I just want to say that, well, both the approaches have their own pros and cons, and it depends upon the scenario and the product and the project requirements in each, what you have and which trade-off you want to choose. So as monolithic approach best suits with the lightweight or the small teams or small application, it is recommended to adopt monolith approach first, and depending upon the requirement or depending upon the scale of your team, you should move ahead and move to the microservice architecture. A small trivia for you folks is, if you folks have used Django, or if you're using Django, what is the latest version that Django has introduced? Okay. Okay, who has Googled right now? Okay, so when did Django actually made the project open source? Okay, the answer is 2005. It was built in 2003, but it was made open source in 2005. Um, in which year first version of Django released? Even I don't know the answer because I didn't add it here. But what is the approximate cost, you think, of the Django project today? It's an open source project, but it still has a valuation. You can make a guess. 50 million. That's 7 times of the actual price. It's $7 million, US dollars. Okay. If you folks have any questions, please ask directly. And thank you for listening, folks. Really appreciate that. And you can, connect with me on LinkedIn or on Twitter, or you can search my name on YouTube or maybe Google as well. You'll find me.
So are there any questions from the floor?
Hello, thank you for your talk. I have a question about, do you have any tips about learning microservices or using Django? Do you have any tips about learning microservices? If you like,
you mean resources?
Or tips or resources?
I actually have gone through a lot of resources. Maybe I can share those maybe via the coordinators. Maybe I can share those. Yeah. And the good part, actually, we have learned it through experiments. It's not like whatever written in books or whatever you see on YouTube or whatever people are teaching. They're more relevant to software engineering or cracking interviews at big MNCs. When it comes to the real world, things get more difficult when you build those. So we actually learn those on the go, and it's not a 1 month or 2 month process. It sometimes takes years. So I worked at Stack Guardian for a year, and we started with a monolith, and along the way we figured out that microservices is something we should move to.
Next question, gentleman over the left side.
Hi. Early on in your talk, you mentioned about microservices having dedicated databases for each one of them. Can you elaborate a little bit on what those, what are the advantages of having dedicated databases? And not just that, a little confused because used to having a single source of truth for data, right?
Exactly. So you correctly mentioned a single source of truth is required. So if you'll have, so each and every service should have a single source of truth. For example, you have a profile service, you have auth service. The auth service should not depend on the profile service, profile database for any kind of information. Maybe it could be a primary key or something, but not the complete data. So whatever, if some external service requires any information, it should get the complete data from the profile service database only. It should not depend, by any way on the auth service. So that's why dedicated databases are required, and it's more preferred. Eventually, you need to create different schemas if you make use of a single database. So it will eventually, you need to scale it vertically, that particular database, if you consider one only.
Yeah, so one question from my side. Can you share a bit more about the serverless architecture?
Yeah. So serverless is actually one of the recent architecture which is being introduced. So what happens in serverless, you don't have to actually care about anything, and you just give all the maintenance about the hardware, about all the management work to a third-party service. For example, my microservices is running 5 functions. A single microservice is running 5 functions. What I can do is I can transfer that responsibility to AWS Lambda, 5 AWS Lambda, and that's what serverless computation is. Serverless architecture is where you delegate the responsibility of, a particular microservice functions to different third-party servers. For example, AWS Lambda or Azure Functions.
Are there any more questions from the floor? Yes?
Hey, hello. How would you compare using Python with other framework in either in Python or in other language when building a large-scale project?
Okay, that's a very good question actually. So while doing our researches, Django is a macro framework which is also known as a battery-fitted framework. And there are a lot of organizations which prefer Django. So there are a lot of actually, platforms like, I guess Spotify is also built with Python only. There are other platforms as well which are built in Django. So the reason we chose Django was, one was community. The community was huge. The second was, it is a battery-fitted framework. It provides a lot of functionalities built in. So that was one of the reasons we actually took this path. There are other reasons also. Building microservices should be feasible. There was a lot of research went into that. But one of the major reasons was the community, and it was open source. Third is the one I mentioned, that it is a battery-fitted framework, which provides a lot of functionalities, and it's very easy to scale. It's a macro framework.
So regarding microservices, do you think there should be a max limit on the number of microservices you should have in a project?
Yeah.
And also, any tips from your experience, any tips on how to manage it, like the release lifecycle, code management, when there are many number of microservices?
Yeah, very good question actually. So when people talk about microservices, they generally think a complete platform should be divided into 10 or 20 or 30 microservices. It's not like that. Generally, a system should only have 2 to 3 microservices. So the only factor one should consider, the major factor is the separation of responsibilities. They should be loosely coupled. It's not like, the dependency should not be tightly coupled. And that's the major consideration one should keep in mind while, so that's what I mentioned in the talk as well. Designing a microservice is actually very tricky, and it's the most difficult part, and requires a lot of costing and documentation as well. What was your second part of the question? So generally, as I mentioned, when the team scales, companies should move to microservice architecture. There, it's kind of a good practice if you're a small startup. Each particular microservice should have an ownership, or 2% should be working on it. And depending upon whatever feature enhancements they're doing, they can, so there is no kind of release cycle thing in it, because they can work parallelly, and that's one of the advantages of microservice. They can work parallelly. They can, for example, if auth service has any changes, they can go ahead with the deployment, and the people who, so one of the ways deployment works is blue-green deployment, if you have heard about it. So if the current service, for example, so it happens in stages. We serve the 50% audience. We started, sending the request of 50% audience to the previous version, and then the remaining 50% to the newer version, and subsequently we moved the older audience to the new audience, and this is how the deployment actually works. And yeah. If you still have any doubts, we can maybe talk.
If there are no more questions, shall we give Mr. Vijay a round of applause?
Thank you, everyone.
Thank you very much. And in this case, we would invite Mr. Sammy Fong, our chairman of the organizing committee, to give closing speech.